In this video, we're looking at conditional probability. So sometimes conditional probability can be confusing, so it's important to really pay attention. So conditional probability is the probability that an event, A, occurs when it's known that another event, B, for example, has already happened. So examples include selections without replacement. So we write the probability of event A happening given that event B has happened as P there, A line B. Right, so there's a formula you can use. Sometimes it's better to use a Venn diagram to just introduce you to what it is. So above, we got a Venn diagram that we're going to use to demonstrate this conditional probability topic. So we're going to find the probability that a student does geography given that the student does history. So that's the key word there that we know we're dealing with conditional. It says given. All right, we're already assuming we're looking at someone who does history, and of those, we're looking at the ones who also do geography. So that condition is that the student does history, which means the sample size we're only looking at is our students who studied history. So what that means is I'm really only looking at this big circle here, okay? That's the circle we're focusing on. We're looking at anything in there. The geography on the right, the 18, we don't need to worry about. We're just focusing on those 12 students who do history. All right. So now, using that big sample size, we're going to look at which of those ones now study geography. So only this part of that big circle up above study geography. All right, so 8 study geography from the sample space we're looking at. So what that means is now we can go and actually find our probability. So the probability that we're going to have geography given, sorry, not that symbol, that's the wrong one, geography history, okay? So that's going to be the 8 people that studied geography over the 12 people who studied history. All right, so 8 over 12, or, sorry, not 1 over 2, 2 over 3, 2/3. So here's another example. We've got an arrow that has a probability of 0.75 of hitting the target. It has a 0.65 probability of hitting 2 targets in a row. What is the probability that the arrow will hit the second target given that it has hit the first? All right, so this is where we're going to be using that formula of A, B equals the probability of A, B over the probability of B. So in our example, we're saying we're trying to find the probability of it hitting the first target given that it's hidden, the second target given that it's already hit the first target. Right, so that up here we're going to have the probability of T2, T1 all over the probability of T1 because that's our condition. So the probability of hitting the both targets, they told us that was up here at 0.65. So 0.6, that looks like a 6, so that's 0.65 over the probability of hitting the first target, which was 0.75. Which ends up equaling 0.867. So we're now going to look at some conditional probability with independent events. So on your screen you can see a number of formula, and the most common example is what you got here. If the probability of L is 0.17 and the probability of L intersection M is 0.0204 and the probability M is that, we need to show that these are independent. So this is where we're going to use the bottom formula just there. So the probability of LUM should equal the probability of L times the probability of M. So this 0.0204 should equal 0.17 times 0.12 which this does equal 0.0204, therefore it's independent. So therefore independent. Conditional probability questions, it's very important that you read them. They can be quite lengthy and wordy and difficult to understand, so carefully read through the questions to make sure you understand what you're doing.